Hey guys, Mr. Burns here with your video for lesson 1.3T, rates and ratios with complex fractions. So in this video, I'm going to start off with explaining to you guys what rates and ratios are and how they relate to fractions and how they're similar to fractions. So let's start off with a fraction. Most of you guys probably, I'm going to say in fourth grade, fifth grade, maybe even earlier, started talking about fractions. Basically, a fraction is a number that compares two numbers. Let's say, like if you're using a tape measure, right? One common fraction you'll see is like 1/2. That's a fraction. Why? Because you're comparing two numbers together. The number on the top is called your numerator. And the number on the bottom is called your denominator. And of course, I'm going to run out of space here. So, right? So that's your denominator. A visual is, let's say you have a circle. This would represent, okay, it cut in half. And then if I was to shade one section out of the two, that would be one of the two sections is shaded. So that's a fraction. See if I can shrink that, set that over there. Yay. Okay, let's talk about ratios. Ratios is commonly used when you're comparing the sizes of two or more objects or quantities. That's one explanation. Another way to explain a ratio is that it compares two quantities measured in the same unit, right? Those are two different ways you can think of ratios. One example of a ratio, let's say, just for the heck of it, let's say you're living in a village where let's say you're living in a part of the country where the ratio of zombies to humans is 50-1, right? So you've got 50 zombies, okay, compared to one human. And you're probably going, well, Mr. Burns, what is the unit of measurement in this case? Well, the unit of measurement in this case, whoops, sorry about that, is humans, right? Zombies are, we're humans, and humans are humans, right? So that would be an example of a ratio. So they have the same unit, human beings, just that zombies are infected with some sort of funky what, I don't know. So anyways, so same unit. An example of a rate, okay, so the definition of a rate can compare two quantities measured in different units. Okay, that would be an example of a rate. One place that you see rates really commonly used is like the rate of how fast a car is going. So if you're traveling at, let's say, 60 miles per hour, okay, per 1 hour, that is a rate. Why? Because the numerator is your distance. I'm going to have to shrink this up a little bit. So the numerator is distance. Okay, and the denominator is time. Those are not the same units, okay, the same units of measurement. They're not the same quantity. They're different, right? One's distance, one's time. Anyway, so that's an example of a rate, all right? So that's fractions. So real quick, reintroduction to fractions, okay, revisiting fractions and rates and ratios, all right? Okay, so let's go ahead and move in. Let's talk about complex fractions. So a complex fraction is just like the name sounds, it's complex. It's a real fancy way of saying a fraction over a fraction. One example of the complex fraction would be like, let's say 1/2 over, 3/4. Why is this complex? Well, because you have a fraction in the numerator and you have a fraction in the denominator. So that would be an example of a complex fraction. All right. So let's go ahead and dive right into the lesson, and go ahead and let's look at it. Here we go. So in this assignment, okay, for examples, for the directions, for numbers 1 through 4, it says follow the directions to simplify each complex fraction, and then use the value to place each fraction on the number line in question 4. Probably due to sake of time, we're going to estimate, okay, and move really quickly through number 4. So don't get too axle wrapped if I'm not really precise, okay? So it's going to be kind of an estimate. All right, so I'm going to blow this up a little bit, make it a little bit bigger so that you guys can see what I'm doing. All right, number 1 says rewrite the complex fraction using division. So you've got 4 over the fraction 1/2. Okay, so what they're doing here is they're going to rewrite it, so they're going to take the numerator 4, set it off to the left of your division sign, and the denominator 1/2, oops, sorry, might be bold, but I'm not perfect. Okay, and they're going to rewrite it over there to the right of the division sign, so 1/2. So it says divide and simplify. So remember KFC, keep, flip, change. So if you can remember Kentucky Fried Chicken, okay, or keep, flip, change, then this is really easy. So what we're going to do in this situation is we're going to keep the first number, the numerator, and again, my stylus is going to give me fits and starts. Okay, we're going to keep that the same. We're going to flip the second fraction, and then we're going to change the division to multiplication. So 2 is the reciprocal of 1/2. So if I've got the fraction 1/2, if I want to change it to its reciprocal, I'm just going to flip it. So the denominator is going to go on the top, the numerator is going to go on the bottom, and then when I simplify that, okay, that's the same thing as 2. You guys with me so far? So at this point, you should be able to do mental math. What's 4 times 2? 4 times 2 is 8. We're going to go ahead and write that right over here. All right. Okay, moving on to number 2. Move this over just a touch. So, and I'm going to move it and shrink it just a touch. Thanks for bearing with me, you guys. Learning to reuse this technology again. Whoa. Okay, moving on. Okay, so number 2, you've got 2/3 divided by 2. It says rewrite the complex fraction using division. So we've got 2 over 3 divided by 2, and when we rewrite that, that's 2/3 divided by, what's the denominator? The denominator is 2. And then it says divide and simplify. So you've got 2/3 divided by 2. So we're going to keep, flip, change. So 2/3, we're going to keep that 2/3. We're going to flip 2 and change it to its reciprocal, which is 1 over 2, or 1/2. And then we're going to change the division to multiplication. So at this point, we're going to multiply these two fractions together. And remember, when you're multiplying fractions, you do not have to have a common denominator. So 2 times 1 is 2. And then 3 times 2 is 6. And then at this point, let's go ahead and reduce our fraction. What's the greatest common factor of 2 and 6? That's the number 2. So we're going to divide both the numerator and the denominator by 2. All right, so 2 divided by 2 is 1, and then 6 divided by 2 is 3. And that is your final answer. Now on number 3, you've got 4/5 divided by 2/10. So again, I'm going to have to move this over just a touch. And I'm going to go ahead and make this a little bit bigger because it makes it a little bit easier for me to write. Sorry about this, you guys. Appreciate your guys' patience with me. So here we go. So let's rewrite this. So we've got the numerator 4/5. And that's divided by the denominator 2/10. All right, and then let's go ahead and keep, flip, change. So we're going to keep the first fraction the same, so 4/5. We're going to flip the second fraction to its reciprocal. So instead of 2/10, it's going to be 10 over 2. And then we're going to change the division to multiplication. All right, so there we go. So I'm going to move this over just a scotch, and we're going to divide and simplify. How are we doing so far? You guys got it? All right, moving over. Oops, I knew I was going to mess that up. Mr. Burns. Okay, so 4/5 divided by 2/10. So let's go ahead and do this. So keep, flip, change. All right, here we go. So 4 tenths, 4 times 10 is 40. Over, and then 5 times 2 is 10. And then what's the greatest common factor of 40 and 10? That is 10. So we're going to divide both the numerator and the denominator by 10. So here we go. 40 divided by 10 is 4. And then 10 divided by 10 is 1. And how many times will 1 go into 4? Can that be reduced some more? Absolutely. So 1 will go into 4 whole times. So my final answer is 4. So for the sake of time, I'm not going to worry about number 4 for this video just because I'm trying to condense, keep these videos under 15 minutes for you guys. So let's go ahead and jump on to numbers 5 and number 6. Okay, so here we go with number 5. On number 5, we've got 6 divided by 2/3. So we're going to take the numerator 6, and we're going to divide it by 2/3. All right, so following our rules for dividing fractions, we're going to take keep, flip, change. So we're going to change the whole number into a fraction by putting it over 1. So 6 over 1, keep, flip, and change. And then we're going to multiply this fraction straight across. So 6 times 3 is 18. Over, and then 1 divided by 2. 1 times 2 is 2. And let's go ahead and reduce this fraction. How many times will 2, do you think 2 will go into 18? Well, 18 divided by 2, if you know your basic math facts, is 9. Trust but verify. If you guys haven't gotten calculators out, go ahead and get a calculator out, but make sure, again, with calculators, it's really essential that you guys show your work. It's okay to check with a calculator, but show your work step by step, what we're doing. Because later on, down the road, when it comes to your tests or reviews, okay, or even future assignments, sometimes if you know these basic math facts, it's going to be faster than using a calculator, I guarantee. But calculators are great tools for justifying and proving your work. Anyways, let's move on to number 6. On number 6, you've got 3/4 divided by 3. So again, 3/4. Let's go ahead and write this problem down. So 3/4 divided by 3. KFC, keep, flip, change. So keep, first fraction the same. Flip 3 to its reciprocal. So put a 1 underneath it. Flip it to its reciprocal, which is 1 over 3. And then we're going to change the division to multiplication. At this point, we're going to go ahead and multiply our fractions straight across. With 3 times 1 is 3 over, and then 4 times 3 is 12. And then we're going to go ahead and reduce this fraction. And what's the greatest common factor of 3 and 12? In other words, what's the biggest number that will divide 3 and 12 evenly? Again, if you know your basic math facts, 3. Trust but verify. I might be bald, but I'm not perfect. Sometimes I make mistakes. Just ask my wife and kids. So here we go. 3 divided by 3 is 1. And then 12 divided by 3 is 4. All right. Okay. Go ahead and let's go to the next page and let's talk about unit rates. Remember, like I said, what rates can be. Rates can, like I said earlier, can compare two quantities measured in different units. Okay, and rate is often used to express speed, distance, or time in certain situations. So here we go with number 7. On number 7, it says 12 over 2/3 of an hour. It says this rate can be also written as 12 over 2/3 miles per hour. So for the next part, it says rewrite the complex fraction using division, okay, which is what they do there. So again, I'm going to expand this out so it makes a little more sense. I apologize if you hear kids screaming in the background. That's your cross-country team. Yay, cross-country. Woo-woo. Anyways, moving on. So it's going to be 12 divided by 2/3. And then it says divide and simplify. So we're going to keep, flip, change. So keep the first fraction the same or rewrite it as a fraction over 1 or a number over 1. And then 2/3. Okay, we're going to flip it to its reciprocal. So instead of 2/3, it's going to be 3 over 2. At this point, we're going to multiply straight across. So 12 times 3 is 36 over, fancy stylus, and then 1 times 2 is 2. And then at this point, we're going to go ahead and change this to a unit rate by dividing both the numerator and the denominator by 2. And it says write your answer with the units in the rate. So 36 divided by 2 is 18. And what is its label? So 18 what? In this situation, it's 18 miles compared to, and then what's 2 divided by 2? 2. And 2 what? 2 divided by 2 is 2. Mr. Burns, like I said, trust but verify. So 2 divided by 2 is actually 1. And then 1 what? In this case, it's 1 hour. Okay, so your final answer is 18 miles in 1 hour. Let's go ahead and move on to number 8. On number 8, you've got 16 feet over a quarter minute. So 16 feet over a quarter minute. So sticking with the same procedures earlier on, let's go ahead and rewrite the complex fraction using division. So it's going to be 16 divided by 1/4. Okay, and the next thing we're going to do is we're going to go ahead and divide and simplify. So let's go ahead and change our whole number 16 into a fraction by putting a 1 over it, or 1 under it. And then we're going to flip the second fraction to its reciprocal, so 4 over 1. And then we're going to change the division to multiplication. At this point, we're going to go ahead and multiply straight across. So 16 times 4 is 64 over, and then 1 times 1 is 1. All right, and there you go. That's your final answer. 64 over 1 what, though? So in this case, it's 64 feet over 1 minute. All right, and that is your final answer. Let's go ahead and move on to number 9. Now, number 9, I'm going to shrink this down just a touch. It says rewrite, for number 9, it says 1.5 inches over half a second. And this says rewrite 1 and 1/2 as an improper fraction first, and then simplify the rate. Hopefully you guys are going to remember how to change a mixed number into an improper fraction, but let's go ahead and do that. So to change a mixed number into an improper fraction, I'm going to take my denominator 2, and I'm going to multiply it to my whole number. And then I'm going to add the numerator. Okay, so 2 times 1 is 2, and then 2 plus 1 is 3. So it's going to be 3 over 2. All right, so let's go ahead and set it up. First thing we're going to do is we're going to rewrite the complex fraction using division. So in the numerator, it's going to be 3/2 divided by the denominator 1/2. KFC, keep, flip, change. So we're going to keep the first fraction the same, flip the second fraction to its reciprocal, and then I'm going to change the division to multiplication. Here we go. So 3 times 2 is 6, and then 2 times 1 is 2. And let's go ahead and reduce this fraction. Okay, so what's the greatest common factor of 6 and 2? That is, in fact, 2. So we're going to go ahead and divide both the numerator and the denominator by 2. And then 6 divided by 2 is 3. And 2 divided by 2 is 1. And then let's go ahead and keep that as it is, as a unit rate. And it's 3 what? It's 3 inches over 1 second. Another way you can say this is 3 inches in 1 second. Okay, on to number 10. On number 10, it says, Tom walked 9 yards in 1/3 of a minute. Assume he walked at the same rate the entire time. So part A says, how fast did Tom walk in yards per minute? So it says, complete the rate given in the problem. So how many yards? That would be 9. Let's go ahead and see if I can do this correctly. And that messed it up too bad, so I got 9. And then my denominator is going to be 1/3 of a minute. So then it says, find the unit rate to answer the problem. So to find the unit rate, we're going to divide both the numerator and the denominator by 1/3. Okay, so let's go ahead and do that here. And again, I'm going to expand this out so I got a little more room to write. So please forgive me. Here we go. So we're going to take the numerator, 9. Okay. And we're going to divide it by 1/3. So in order to do that, we're going to take the whole number, put it over 1, so 9 over 1. So keep, flip, change. Then at this point, we're going to multiply straight across. So 9 times 3 is 27. And then 1 times 1 is 1. So it's 27 what? It's 27 yards. Okay. In or over 1 minute. Okay. So that's for the last part of part A, where it says find the unit rate, okay, to answer the question. So then on part B, it says, at this rate, how far did Tom walk in an hour? So in this case, off there to the right, it says, think about how many minutes there are in 1 hour. There are 60 minutes in an hour. So let's go ahead and rewrite 27 yards. So we got 27 yards in 1 minute. In order to change minutes to hours, we're going to have to multiply. So what are we going to multiply by? There are 60 minutes in an hour. So we're going to multiply 1 times 60, and that'll give us hours. Okay, so 1 hour. And then whatever I do to the bottom, I also have to do to the top. So let's go ahead and multiply 27 times 60. Use your calculator, and you go 27 times 60. You should come up with 1,620. And 1,620 what? That's going to be yards. And that is your final answer. All right, so good luck on your assignment. I don't know if it's going to be the practice worksheet or if it's going to be a book assignment, but best of luck to you. If you guys need any help, make sure you ask either me, the substitute, or the teacher, and we will be more than happy to help you guys out. That's all I got. Mr. Burns, out.